Hello, my name is James Halderson, and I am the lead developer and currently only developer on the Virtua Cash project. So, this is the Virtua Cash project functionality outline, and it's a PowerPoint presentation that we're going to look through all the different aspects and software mechanisms that go into the Virtua Cash ecosystem. Firstly, we'll just go into the general idea is to create a networkless offline cryptocurrency with fungible exchange capability mirroring tangible cash but through a virtualization of the concept, utilizing device-to-device transmission and transactions. Rather than using an online blockchain network, which in practice always becomes a centralized concept, Virtual Cash will instead utilize localized blockchains and hybrid encryption, borrowing from the block matrix concept I previously developed through the Thetis project. In order to achieve this, the project will consist of several software mechanisms that will be orchestrated through a generalized application layer. So we'll look into those individual software mechanisms in a second, but firstly, just to look here, this master architecture plate showing how everything works in this system. There's a Genesis layer, which is its own application, and this Genesis generator layer is actually the thing that creates all the denominational assets for the virtual cash currency, which we'll go into in a couple minutes, I should say. Next, we have the device layer, or the wallet layer, which is on each individual device, which contains its own blockchain and its own encrypted assets. There's a transport layer, which is an offline transaction session that happens between devices. So essentially, it's 3 layers deep with 2 different applications in the ecosystem. And we will go into more about each one of these software mechanisms and how they interact with each other in a second. So on to the second slide here. We're just going to look at the major software mechanisms here. So as I mentioned, there's a Genesis generator and central bank, which will produce all denominations of virtual cash currency system and embed them with a verifiable digital signature that validates that each note was genuine and created during this Genesis event. There's a wallet system, which will contain the user's information encrypted using quantum-proof symmetric encryption. A localized blockchain ledger, unique to each user, which records all of their transactions and generates a unique hash that is then stored within their fungible assets through steganography, which we'll get into. A steganographic image file storage system, which stores digital signatures within encrypted image files representing various denominations of virtual cash currency system. And lastly, a transaction and transmission system, which contains multiple software subroutines and facilitates transactions through a hybrid encryption mechanism. Each of these software mechanisms constitutes a facet of the whole system and is facilitated by the generalized application layer. In the following slides, each mechanism will be expounded upon in detail to explain how the system as a whole will function and what advantages this offers over centralized blockchain networks and currently available cryptocurrencies. So we're going to look at this little offline currency architecture diagram here. We see that there's the Genesis generator and the virtual central bank here, which issues notes and coins. These go to the wallet, the user wallet, which is the application layer. We're going to be doing this in Maui, .NET Maui. So all the code will be in C# and will also be in XAML for the front end through the .NET Maui, through the .NET Maui development environment. And then there's the offline transaction session, which these sessions are created by the app itself, and those sessions then facilitate the transfer of blocks and as well as asset transfer using ephemeral transfer keys. But we will get into all of this when we get to that offline transaction session slide. So firstly, we're going to look more in depth at the Genesis layer, the virtual central bank. As I mentioned prior, the aim of this project is to create a virtual currency that is distinct from a centralized blockchain network, creating an anonymous, localized currency which is exchangeable device to device without the need for an online connection. In order to facilitate this functionality, the first phase of the Virtual Cash project is the Genesis layer, which will generate all the denominations of Virtual Cash currency in a single event. This apparatus will then encode these denominations in the form of an image file representing either a note or a coin as denominational values of Virtual Cash with traceable algorithmic digital signature that is therefore utilized to validate and verify these notes or coins. The Genesis generator will create a digital signature for each denominational asset using a unique cryptographic process and an RSA private public key encryption. The Genesis generator will have its own localized blockchain ledger. As the notes are generated, a block is created within the blockchain ledger that contains the Genesis event information, including the monotonic incrementer that denotes which iteration each asset was generated on, the timestamp for that generation event, and the phrase, "This is a valid certificate." Concurrently, this same block of information is encrypted using an RSA private key public key pair, resulting in an encrypted string which is then injected into the denominational image file of that asset through steganography. The wallet application is then distributed with the public key and can decrypt this image, which allows the application to validate that the note indeed did originate from the Genesis printing event. Furthermore, after the initial generation event is completed, a virtual central bank will hold all denominations until they are obtained by the users of the Virtual Cash system, which distributes these notes or coins to the user base. Once a denominational note or coin is obtained from the virtual central bank, it can be freely traded on the open market offline and device to device as long as the digital signature that was instilled into the note by the generation event at the time of its initial creation can be verified and validated. This verification and validation workflow occurs offline and between devices, with no need to check back with the virtual central bank. In such a case, though a centralized Genesis event is required and shared between all denominational Virtual Cash assets, it is a one-time event that allows for truly decentralized offline exchange of assets once these assets have been obtained, which mirrors the accessibility and functionality of paper fiat currency. So that's quite the mouthful there. You can go back and pause these slides at any point in time and read them for yourself. We're going to look at this diagram here that kind of explains in more detail. There's two diagrams, but they kind of fit together. So the first part of it, the Genesis generator, we initialize the Genesis block for this blockchain, and we start a counter at 0. We then loop for each denominational unit. We increment the counter, create an issuance block, which has the denomination, counter, timestamp, as well as the information like this is a valid certificate, and we hash this block. We then take this hash of the block and we encrypt it with the private key, and we embed that encrypted signature now steganographically into the asset. And then we take this asset and we're just going to store it on the internet in a central bank vault until it is obtained. So this process of creating each bill, let's say each note, that creates a hash of that creation event for each one of the notes, and we then instill that into each one of the notes steganographically. Using that signature, we can then check later with private key, public key encryption and decryption. We can decrypt it with the public key that inside the app, and we can see that this indeed came from that Genesis issuance event. And the only reason why there's a central bank needed at all is just there has to be somewhere to store these. After they've been generated, they're just being stored somewhere. That'll probably be online in a database somewhere, and then people can obtain these through either like trading in some way for these notes. Basically, it's essentially like any other currency exchange. We'll go into the second part here. We have the Genesis generator and the issuance event. That's what this is called because it's issuing each one of the notes. That instills each one of the assets with this key signature of that event, which that key signature also includes the information from when it was generated on the blockchain. And then these are put inside of your wallet. They're stored inside the user wallet. Once they've been obtained, they come down, they're in the ecosystem now. And when they're in the ecosystem, they exist inside of a wallet. And offline transfers can be facilitated between wallets and never checks back to the central bank. That's only there in order to hold assets until they enter the ecosystem. When they enter the ecosystem, everything is done device to device. So that's a little breakdown of the Genesis layer and the virtual central bank. We're going to move on to the next slide here. And this is the wallet system and the symmetric encryption layer. So again, we're going to have another read through of these couple paragraphs, and then we will talk about the diagram on the side explaining this in more detail, kind of visualizing how this will work. So the generalized application layer essentially functions as a familiar wallet application on your device. This virtual wallet has a containing folder which holds the virtual cash denominational assets, which exist themselves in a folder format containing encrypted image files. Within these encrypted image files are contained steganographic digital signatures. One from the Genesis event, which confirms the validity of the virtual cash asset, and another which is generated by the local blockchain ledger as a hash, which verifies that the virtual cash denominational asset belongs to its current containing wallet as an anti-piracy and anti-counterfeiting measure. Along with facilitating the cryptographic and steganographic security of the virtual cash denominational file types, the application will also offer an easy-to-use and intuitive UI to the user in order to manage and exchange their assets, allowing them to view the denominational notes and coins within their possession and to complete transactions with others through a transactional mechanism that will be discussed later in this document, or this presentation, I should say. These assets will be protected through a unique symmetric key encryption implementation. When a wallet is first created by the user, a symmetric key is generated, and a symmetric key encryption is then utilized to encrypt any assets that the user holds. When a transaction is completed, however, a new block is added to the localized blockchain, and the hash value is altered. This new hash value is then embedded in the denominational assets, and the wallet holds through a steganography as a digital signature. All the assets are then encrypted with the current symmetric key and now contain a unique signature that identifies them as belonging to the user who transacted these assets. These symmetric keys can also be rotated, leading to another layer of cryptographic security that prevents against privacy and makes it virtually impossible to steal these assets from the user to whom they belong. For if the files are somehow intercepted and removed from their containing folder, the thief would not only have to have the symmetric key to decrypt the file, but would also have to replicate the hash produced by the localized blockchain hash function in order to prove that the asset belongs to them. This multi-layered and multifaceted approach makes local asset storage safe and practical. These more complex software mechanisms are obfuscated from the user behind a simplistic UI. The inner machinery of the application layer completes these complex encryption tasks in the back end and away from the UI layer that the user interacts with. The UI layer also allows for safe and optional storage of user information at local level, including their first and last name, phone number, and personal PIN and key, that can also be optionally utilized to verify the user during the transaction and transfer stage. Any provided user information can then be encrypted using symmetric key or utilized as a seed in the accompanied localized blockchain ledger document itself as encrypted with the symmetric key in order to produce hash values, and consequently the digital signatures that are utilized in the cryptographic security layer as mentioned in the above paragraph. So there's a lot going on there. We can look at these diagrams here to get kind of a better idea. So on one side here we have the wallet side, and on the other side we have the blockchain, which is then owned by the wallet. But when the wallet is initialized, this generates a symmetric key. These symmetric keys can also be rotated out at any point in time. This key is then used with the symmetric encryption engine to encrypt anything inside of the wallet that belongs to it. So we can think about the blockchain as belonging to the wallet, We can think about the assets themselves as belonging to the wallet. Anything that belongs to the wallet is encrypted with this encryption key. For this specific little diagram here, we're looking at the localized blockchain ledger. When the ledger is altered, this computes a hash, and this hash is then sent down to the encryption engine, and it uses your symmetric key from your wallet to then encrypt the hash that's coming from your blockchain ledger. When you encrypt this ledger, or this hash that came from the ledger, you then bind your denominational asset to that blockchain. So whatever the hash is of that blockchain has then now created a digital signature using this symmetric key, and that is being stored inside of your assets through steganography. So to kind of simplify that a little bit more, you have a symmetric key, and the symmetric key is used to encrypt everything inside of your wallet, and all the things that belong to you inside of the application, all its containing folders. When changes are made to your blockchain, these hashes are then also encrypted, and this encryption creates a signature that is then put into your asset. So each asset will then own, if I spent something or if I traded with somebody, those changes to the state will then create new hashes that are then re-encrypted and then stored inside the denominational assets, and the old ones are removed. So what you have basically from this process is you have a state machine that's constantly mutating. It's a mutational state machine. And the state of your wallet and the state of the assets in the wallet are always changing based upon whatever actions you're taking. And because of this, it's not possible for somebody to replicate all of those changes, all those state changes from outside without having that blockchain, the local blockchain, to roll back and look through all the different changes that you have made, all the different states and the hashes that have been produced. Because on a blockchain, each block that's hashed, it requires the hash of the prior block before that, and it's just a machine that goes all the way back to the Genesis block, and there's no way that if you it's immutable. If you change any byte, a single byte or a single bit of information inside of that blockchain, everything breaks down, and the denominational asset, when the wallet pulls up your assets, it's going to check to see, hey, is that signature in there the same as what's currently being produced by the state machine? And if it says no, these don't match, that's it. You can't use those assets anymore. So it's impossible for somebody, if somebody tries to mess with any one of these mechanisms at all, they'll just break it, and there'll be no way for them to steal that from you. There'll be no way for, like, it won't create usable notes after that. It's broken. If you can't verify the hashes, if you can't verify the digital signatures, it breaks. And that's by design, so that people can't steal. There's no way that you can steal this from somebody. It's an immutable blockchain and a mutational hash machine fused into one system. Anyways, on to the next thing. And this is part of that whole mutational system and the state machine, the ever-changing state machine. We're going to be talking about the localized blockchains and block transfer mechanism. So, traditionally, a blockchain is shared immutable ledger that uses a hashing function to verify and validate that all previous blocks on the blockchain going back to the Genesis block are valid. This is achieved by creating a hash of the entire blockchain and checking its validity. If the hash is valid, the new block is added and the new hash is created. Typically, this entire process is done through the consensus on a peer-to-peer network or client-server network, which similarly have all the peers on the network validating blocks. When such a validation occurs through consensus, a new block containing multiple transactions is added to the blockchain. Virtua Cash Virtua Cash instead will utilize localized blockchain and block transfer mechanism. Each individual user's wallet has its own blockchain, which records and denotes all their individual transactions locally on their own device. This blockchain is encrypted with their wallet's symmetric hash and utilized in order to produce a digital signature through a hashing algorithm that is instilled into each of the image files of the virtual cache assets stenographically. When a transaction occurs, a duplicate block is also created and sent to the recipient. Upon receiving the duplicate block, the recipient then adds this duplicate block to their localized blockchain and validates their blockchain, given the new information. Upon validation, the recipient now creates a new block and sends a receipt in the form of their own duplicate block to the initiator. Upon receiving this duplicate block, the initiator also now adds the block they received to their localized blockchain and validates their localized blockchain. This is how the block transfer mechanism will operate. As a consequence, both the initiator and the recipient will now have a record of the transaction that occurred in the form of transaction blocks and receipt blocks that were sent and validated by each other's localized blockchains. There are several advantages to using localized blockchains and block transfer mechanism in the manner described above. Firstly is the energy saving potential. Traditional blockchains use an exorbitant quantity of energy and require entire data centers in order to function at scale, which puts a tremendous strain on the power grid and electrical resources for relatively minimal benefit. On the contrary, utilizing localized blockchains and block transfer mechanisms requires virtually nothing in terms of energy resources. Even at scale, it is able to be completed at a local device level on any smartphone or home computer. Another advantage is that even though this methodology uses virtually nothing in terms of energy and consumption of electrical resources, it creates a cryptographic mechanism that is much more secure due to the variability of the resulting hash algorithm-derived digital signatures that are utilized to endorse ownership of virtual cash assets. As each time the localized blockchains are altered, a completely new hash is created from these alterations, which creates so many permutations and possibilities cryptographically that no machine in existence will be able to replicate this mechanism, making it quantum proof for the foreseeable future. So this is quite the... I'm just going to click here and click again because this is quite the mouthful there. We have a little thing here to describe these blocks, and this is pretty complex. So essentially what's going on here is that let's say we have device A and we have device B here. Each device has its own localized blockchain. So these are blockchains that are local to device A and local to device B. When some action occurs on the network, let's say device A is the initiator, device B is the receiver. Device A creates a block and then validates it on its own local blockchain, and this creates the current ledger state hash. Once that block has been hashed and validated to say, hey, this block is definitely valid on this side of the blockchain, a duplicate of the block is then sent over through this temporary transfer channel to device B. So then they receive the block that I sent over. They take this block, they add it to their blockchain, they validate their blockchain, they get their ledger state hash for ledger state hash B. This is then stage 1 of the block transfer mechanism. They have now validated and have a duplicate block of the block on my blockchain, which is now on their blockchain. Now that they have done that, they will send me a receipt block. Say they do the same thing. Device B's blockchain creates a new block. It validates this block by hashing it and checking the hash value. It sends me the block to device A. I then receive a duplicate block. I add that to my blockchain. I validate it. I hash it. Everything is hunky-dory. It checks out on my side. It checks out on their side. Then we can then initiate a transfer of actual assets. So this is just showing like how the blockchain works here. So we have the monotonic counter, of course. It can only go up, it doesn't go down. So we have block n and block n minus 1. So the way that a blockchain works is that if I have block n, then I also take block n minus 1, which is the one before n, and I take both of those hashes and I hash every block before I go back, block n minus 2, block n minus 3, back to the genesis block, and I create hashes for each one of those, and I check to see that each hash with block n and block n minus 1 are valid. I then, if all those check out, then I come to my current block and I hash the block that I just created or the block that I received. And then I get a new valid ledger state. And this then works with the asset binding engine that we talked about before, which was with the cryptographic asset, where I take this hash from my local. So after all that happens that I talked about, where I send a block, they validate, they send me a block, I validate it. I then take the hash of that operation, of how the state has changed in my state machine, and I then use this as an encrypted digital signature, which I then put into my assets, which are then stored in my wallet application. So there's a lot going on here, and it's because of this complexity that it's just going to be so much more cryptographically sound. It's the way the system operates. It's just so much more complex, and it's actually intuitive. Even though there's a lot going on here, it makes a lot of sense because the after this operation has occurred and I get back a hash from my block, sending it to them, their block coming back to me, I have a hash of that. This then denotes and signifies that some kind of activity has occurred, right? And then if I take that and I store it inside my note, and I check for that all the time to make sure that, hey, did all these actions occur in the proper order? Is everything checking out, right? Is this ledger accurate? Then I can validate that, yes, the note that I'm using it's currently in my wallet. It's been here, it's been there, it's been everywhere. All of that information is verifiable because that hash, that state has to remain valid. If I get it and it doesn't have, like, that state doesn't check out, then it's counterfeit. Obviously, if the state doesn't check out and I don't have these, I can't validate and verify that, and or if I'm sent somebody's note with the wrong state, there's just no way to counterfeit that. It's always encrypted with, it's always instilled with and embedded with the proper state from the containing folder. And if any actions happen, then the state changes. So again, it's just the idea that it's a constantly mutating state machine, and we're using immutable blockchains to generate states for the state machine. That is the premise behind how you can create localized security, localized privacy and security using, like, in a blockchain environment without needing to go and check on a blockchain somewhere, because we're all sharing information in this ecosystem, but through just passing it locally, device to device, and using the brilliance of hashing algorithms to be able to verify that that information is indeed valid. So next, we have the steganographic. Am I on the right page? Yeah. Okay. Second to last mechanism, we have the steganographic image file storage system. So we briefly explained in the above sections, the prior slides, that this will go more into detail about the steganographic image file storage system and how this software mechanism will operate to ensure the cryptographic security of all virtual cache denominational assets in production. As explained in section A, which was the Genesis generator section, when the assets are generated, a cryptographic signature is applied to each of the Genesis generator mechanism and stored through steganography inside each of the assets. These signatures will thenceforth be utilized to verify and validate that all virtual cache denominational assets were created during this Genesis event. Concurrently, as the user engages in transactions with other users, a hash value is produced by the user's individual localized blockchain, which is embedded through steganography again within the associated image file for all denominations of virtual cache assets. In this way, the encrypted information contained within a virtual cache asset is continuously mutating through expressions that represent the user who currently owns the asset, which makes piracy and counterfeiting nearly impossible. These mutations also occur whenever a communication or transaction or transmission of information is completed between two devices within the virtual cache ecosystem, which makes duplication impossible, as the entire hash of the localized blockchain must be reversed for the virtual cache asset to register as currently valid. Okay, so we talked a little bit about this already, about the whole idea of state machines, but we're going to look at it now from the virtual cache assets point of view. So in our diagram here, our steganographic image file storage system for the virtual cache here, we have our Genesis generator, like we talked about in section A, which was the first mechanism we discussed. The Genesis signature then has the proof of origin, which this is embedded into the virtual cache asset, as well as this proof of origin being put into our virtual cache asset. We also have the ledger state of ownership here, and which is created by the validation engine. So we have this private public key pair. This is stored inside of each asset that was created, which has a visible image, as well as hidden steganographic payload, which is encrypted by that Genesis generator event. We also have our validation engine, which this is the whole thing about the blockchains, and those blockchains creating a hash of the blockchain, and that is then encrypted with the symmetric key, and that encrypted state is then stored inside of the virtual cache asset as well. So we have this asset that is then also encrypted with the symmetric key itself. So it's multiple layers of encryption on one single image. The image contains encrypted information. The image itself is encrypted by the wallet application. So essentially that's about it. Like it seems super complex, but it's just these mechanisms create digital signatures. Those digital signatures are then stored inside of each one of your assets to prove that the asset belongs to you, and to also prove that all the events that occurred beforehand check out and are valid events, valid transactions, valid transfers, valid trades, whatever. And all of that information is then being stored inside of this virtual cache asset, which is an actual note. Like it's like a bill. There'll have to be like images generated for this or created for this whole thing. So I don't know what those are going to be yet. I'm still in the conceptual phase right now. But we have one more page to go through. And this is probably the most complex mechanism out of the whole entire system. So we're just going to get right into it here, the transaction and transmission system. So transactions are facilitated through a multi-phase transmission system with an initiation phase, an initial block transmission phase, an asset transmission phase, and a final receipt block transmission phase. During the initiation phase, a transaction is initiated through one of several methodologies, either using a QR code or NFC communication event to set up the communication channel between devices through Bluetooth or local Wi-Fi. Once a communication channel has been established, the initiation block phase begins. Firstly, A symmetric shared key is generated. This is your ephemeral key, and then sent over the channel to the recipient. A transaction initiation block is then encrypted and sent from the initiator to the recipient, which is decrypted and is then confirmed and validated on both localized blockchains, as we talked about before with the block transfer mechanism. The recipient sends back a block of their own to the initiator, which is also decrypted with the transfer key after being received, validated, and added to the initiator's blockchain. After this initiation phase has completed, the asset transfer stage begins. The assets that are to be sent to the recipient are encrypted with the temporary transfer key, sent over the communication channel to the recipient, and then decrypted on the other end. Finally, a receipt block is encrypted and sent through the communication channel to the initiator, which is then validated on both the recipient's and the initiator's individualized local blockchains. This results in a new finalized state for both blockchains involved in this transaction. After the transaction occurs, a new hash is created and used in the steganographic signature of the transferred assets. The entire asset portfolio is then encrypted with the symmetric user's wallet key, creating a new mutated cryptogenic state or cryptographic state. So, what's going on here in a little more detail when we have this diagram to kind of show and walk through each of the stages. The first stage is that we have phase 0, which is the channel initiation. So this is with QR or NFC. So the first thing is either you scan somebody's QR code off their phone to initiate the channel, or you use NFC, so I tap my phone to the other person's phone, and that either one of those two methodologies sends a signal, and that signal is recognized by the app and says, hey, it's time to initiate a transaction between two devices. So once that happens here, we have phase 1, which is the key exchange. So we generate this temporary transfer key, the ephemeral key, and then we send this key over to the recipient. So whoever initiated it creates the key, sends it to the recipient. The recipient now has this ephemeral key, and this key is being used for encrypting traffic through that channel, that temporary Bluetooth or Wi-Fi channel. So then we have phase 2, which is the transaction initiation block. So this again we talked about with the blockchain transfer mechanism, and the block transfer mechanism is that I create my block, I check and validate the block on my end. Once I have completed that whole check back to my Genesis block, I send my initiation block to the recipient device here. The recipient device then validates the block here, and then it sends me back a receipt block to say, hey, yeah, I have gotten your request for a transaction. I get that back, and I then validate it as well. So there's a lot of validations going on here. One single transaction event will probably have multiple blocks to denote that. Like on my blockchain, I'll have a block that says I started a transaction, and then that will say, hey, let's say the Alice and Bob example. Let's say I'm Alice. It'll say Alice started the transaction. I'll then send a block, and their blockchain will have that same block and say Alice started this transaction. They'll send back a block. I get that block back. It says, hey, Bob received my request to start a transaction. Once both of those have been validated and verified, phase 3 begins. And what this does is this actually, I send out, like I decrypt my assets. I rebind my asset temporarily. I'm just putting in something that says the signature that shows that this initiation and receipt block that I got to start up the transaction in phase 2, that is rebinded, and then I can send that asset over When they receive that asset through the, it is encrypted with the ephemeral key. When they receive it, they decrypt it with the ephemeral key. It'll then have temporarily my signature. They get rid of my signature, and they'll put their signature in there that comes from all their operations they just did here. Finally, they start up a block now, and this is the final receipt block that says, hey, I've received my asset from you. Bob has received the asset from Alice. They send me back the encrypted receipt block again using the ephemeral key. I get back my block on my end. I decrypt it with the ephemeral key, and it says, hey, Bob received the asset. And I'm okay, good. I then encrypt that onto, add that block to my blockchain. I then hash my blockchain. They hash their blockchain. And then what happens at the end is the phase 5 is a post-transaction mutation. So again, this is all state machines. So the state of both ends after all of these operations have occurred have changed. So now that they have changed, they're going to want to take that state change, that mutagenic state that they have now created, and they're going to put that into steganographically into the node. So it's now changed hands because my steganographic signature that I got from my blockchain hashing and everything in the prior steps, that's gone now. They've now put theirs in, which then says, hey, Bob is the new owner of this asset, and Alice is no longer the owner. We then use those state changes in our state machines to then, we encrypt the whole entire portfolio again. So all of my assets and all of their assets are encrypted again with our wallet symmetric keys. So it's no longer using the ephemeral key at that point. The ephemeral key will be discarded. It'll be a brand new one generated each time that you do an asset exchange. So this Alice and Bob thing here, this just shows again basically what we went through in the more detailed diagram. It's just showing that there's the QR code initiates it. We do our encryption and decryption. We get our blocks, right? After we do everything and we have assets that have been transferred, we then bind the assets to the wallet hash, and I bind my assets to my wallet hash. And that's basically about it. So we'll come back to the first thing here. These are the final words here I'll just go into now that we've described everything. We can kind of see how, now that we've gone through the whole ecosystem and how everything will work in the Virtual Cash project, this master architecture plate will make more sense. So the Genesis layer again is its own mechanism. It's a application of its own. This side of it will probably be just a web application, and it'll generate the notes. It'll instill them or embed them with that initial RSA key for its that digital signature that it will be in each one of the notes, and then that stores that in a database that people will trade. You can trade to this database. So far it's just a one-way thing where you just trade something to it. I don't know, it could be real money, it could be cryptocurrency. It's something like there will be some web application layer for trading something in and then receiving your virtual cash assets out the other end. Once you have those assets, right, once you've gotten them from the virtual central bank, let's say, there's no more need to communicate with that web layer. That web layer is just for the generation side of things. It's just to be easily accessible by multiple people. There's no need for you to come back and phone home and check in with that online layer. Once the nodes have entered the ecosystem, we can then see here that we have user device A and user device B. And this is when all the other stuff we talked about with symmetric keys with the individual blockchains, the block hashing, generating ledger hashes, and storing those inside of our assets. All of that happens on this layer here. And the third layer, the offline transaction and the transaction um, the transaction and transmission system. This is just happening. It's basically a third layer. It's like a LAN network layer that is facilitated device to device. So that's the general gist of the Virtua Cash project. It's, again, offline, device to device, no centralization, no needing to phone home or anything like that, no online activity. It can be traded offline exclusively. It's designed to be traded offline as if it was like cash. It's the concept is designed to be anonymous. It's also designed to be like anti-censorship, able to, get away from actual central banks. Even though I'm calling it um, the central bank layer after the Genesis event here and the virtual central bank, this is just kind of a term of phrase. I don't necessarily want to exactly emulate how central banks work. The idea is to kind of get away from central banks and fractional reserve banking, and it's the idea hopefully will be some kind of replacement for these systems that these elite classes and the billionaires and whoever else, the corporations and the fucking banking cartels are using to control finance. It's designed to be revolutionary in the way that it allows people to have a technological way to communicate with each other, and this is without online. So like in regions of the world, in conflict zones or something, as an example, where there's no internet. Oh, the internet's been taking out the EMP. Something happened to our, to our logistics, our infrastructure, our internet infrastructure. Well, if that happens, let's say that something like that happened in EMP or in a war zone, like a war happens, and they're targeting obviously logistics and technological facilitation of intelligence between people and all this kind of thing in the military. How would you ever use Bitcoin or Ethereum or something like that safely in that environment? It's all facilitated on the internet always being online and always being available, and that might not be the case, especially with the state of chaos and disorder we're seeing in the world right now. There might not always be a case for constantly online systems. So it makes a lot of sense to try to create some kind of future thinking, forward thinking way of having people facilitate transactions and interact with each other financially without requiring reaching out to these systems that might not be available. So that's the general idea. The idea is to you know, kind of build a better system, make a better mousetrap when it comes to decentralized finance, to not be so reliant on um, online, you know, on the banks or on centralized agencies and centralized exchanges, I should say, that require all this KYC and you know, they require you to give them your tax information, and it's such a scam and such a scheme to there's so many people have their hands in the cookie jar, and at the end there's barely anything left for the normal average Joe. This again, we can talk here a couple things before I go. There's no mining here, right? Like each device mines itself. It's a proof of origin concept. Like everything is based upon the idea that it's cryptographically sound and that each node can be validated back to the Genesis event, and you can see the transactions that have occurred through digital signatures that are left behind. Like the note carries with it signatures of how it's been operated on. Um, there's no transaction fees. There's because it's just device to device. There's no real network that has to be facilitated, and they don't have to pay transaction fees and gas fees and all these, like energy on Tron and all these other ridiculous ways of, extracting a little bit of wealth from you everywhere along the way, and before you know, you've lost 15% of what you have just from moving an asset from one place to another. So that's the general idea of the virtual cash project. It's something I really want to work on. I've got it conceptually. The Thetis project that I worked on before, a lot of the code can be recycled from there. It's just making a new application. I can get rid of the networking stuff I was doing and just make it like facilitated device to device. Like, I'm capable of building this. So if you're interested in, tagging along and seeing what I'm up to, I will do more devlogs as I work on developing this. Right now, there's no way to really support me, but if you do want to support me, I'll try to set up those avenues in the future. I'll make a Virtua Cash website for this in the near future, and I'll start working on devlogs for my development progress. Anyways, that's it for today. This is me. Any questions, ask in the comment section. Send me a direct message, whatever your preferred method. I'll try to get back to everybody. Thank you for tuning in and checking out the Virtua Cash project functionality outline. Bye.